And today we'll show you how to bring up a component with any dev board in less than 5 minutes. First of all, I'm connecting MPU to a prototyping board and wiring power, ground, and then I2C connection. I will then take it up and do the same on the host board for STM32. So now we are connecting the power and ground, and we have I2C connected successfully and USB-C plugged into the board. Now let's go and power up the computer. So now I'm in the Embedd platform. I go to MPU 6000 and open Components Digital Twin. Go to General Info and I have all of the basic device information here. I select the bus and make sure that the address is correct. All of the registers are extracted for you with information, the names, addresses, access types, etc. As we go to setup, we can then actually see what we need to do to set up and configure that device. So we need to configure power management 1 register, and we'll need to select appropriate power mode and clock. To do that, we select power management 1 register, we add it to the setup list. We can check for additional context in the datasheet with everything backlinked here. So in this case, we'll need to make sure that the sleep offset is set to device awake. And this is done already, so we can proceed to formulas, add a combined register for acceleration on x-axis, let's say, and select registers associated to that. So in this case, it's going to be acceleration x out H and x out L, so high and low bytes. Now we can create a formula. So again, the name acceleration x, and we can add register. In this case, it will be a combined register of axle x. For this situation, we'll need to divide this by 16,384. And now we can say that. That will give us an actual value for acceleration on x-axis. So we can go and click Generate Testing, which sets up a testing environment, where first of all, we select the board we are using, and in this case is Nucleo H503RB, and click Flash. Now what we do is we assemble firmware for the board with the driver for MPU 6000 generated and flash it onto the board itself. We can then click Connect, select the COM port where it's connected to, and as purple circles appear, we can see that we now have live register readings. So you can see here how they're updated in real time. We can also create time series, so you can select registers you want to use. In this case, let's say acceleration X and out L and H, and we'll see both readings on the chart in live. So as I actually move accelerometer, you can see how readings are changing. You can also create charts with formula values that's processed. You can create CSV files with logs, and you can export that. So in less than 5 minutes, we were able to get this component up and running, connected it both physically and on a software level. We were able to get live register readings and plot them on a chart. Stay tuned for public release.